In this video, we are looking at another important step in linear regression, that is assessing for interaction effects among your independent variables in linear regression using STATA. In our previous episodes, we've looked at how to check for assumptions and how to choose variables, and we shall also be looking at step 4, confounding and interpretation of the results in our subsequent episodes. Consider liking and subscribing to the channel so that you don't miss out any of our episodes. When the effect of one variable on the outcome depends on the levels of another variable, that's what we call interaction. To understand interaction terms and how they are created, let us consider a hypothetical data set which has our outcome as systolic blood pressure, and then we have 4 independent variables: age, BMI, gender, and smoking status. You want to find out, is there any interaction among any 2 variables in my data set which would affect the way a particular variable influences my outcome. For example, you want to know whether does the effect of age on blood pressure depend on someone's gender. If yes, then we would say age and gender interact. We have to first test whether there is interaction. We start by creating interaction terms. Interaction terms are basically product terms of those 2 variables. We'll just get this variable times this. We generate a new variable that multiplies this age times gender. So that new variable is what we call an interaction term between age and gender. Another question now comes in. Yes, I have very many variables. How many interaction terms can I form? Before you answer that question, you need to consider 2 things. 1, do you have a main exposure in your study or not? When we say there is no main exposure, it means you have plain questions. For example, what are the factors associated with blood pressure? So you are not fixing any of these independent variables to be a main predictor or a main exposure. All of the variables are equally treated as potential factors associated. If in your research you do not have a main exposure, you've answered condition number 1. Then the next condition is, what is your sample size? If the sample size is adequate, and by adequate we mean at least 40 cases per variable that you want to create interaction terms for. I have here 5 variables. So for me to have adequate sample size, I would need 5 variables times 40 cases. That's about a sample size of 200. So if I have at least 200 participants, I would consider my sample size to be adequate. So I create interaction terms for all the variables, the independent variables. Creating interaction terms is basically generating new variables that multiply 2 variables. For example, we have the first interaction term would be a multiplication between age and BMI, age and gender, that would be 2, age and smoking status, that would be a third interaction term. Then we would also have BMI and gender, then BMI and smoking status. We would also have interaction between gender and smoking status. In that way, we shall have exhausted all potential combinations of our 4 independent variables. So this would give us a total of 6 interaction terms, as you see them on the right here. After generating those interaction terms, we fit them in the linear regression model together with the original variables, and we see whether those variables are statistically significant. Any interaction term that turns out to be statistically significant, then we say those 2 variables forming that interaction term are interacting. So there is interaction in our linear regression model. So let's see how to do this in STATA. So this is our hypothetical data set with blood pressure here, age, BMI, gender, and smoking. We are first of all assuming we do not have a mean exposure and our sample size is adequate. So we shall form interaction terms among all the 4 independent variables. To create these interaction terms as new variables in our data set, simply go to Data, go to Create or Change Data, and you create a new variable. In this dialog box, we are going to specify the name of our new variable, which is age, BMI, and then we shall specify our expression here by saying create. And once we click create, we are going to click on variables here, and we are creating a multiplication between age. So double click on age, then again put a multiplication sign, and then the BMI. Then click OK. So that is the expression we are using to create our new variable, and then click OK. So a new variable called age BMI has been created, and the command you would have used is just generate age BMI equals age times BMI. When we browse our data, we can see that we have a new variable, which is simply a multiplication of this and this to get that. In a similar way, we shall create the rest of the interaction terms 2 up to 6. So here I've created all the interaction terms. If we browse our data, you can see that we have all our 6 interaction terms that we saw in our PowerPoint. Next, we shall run a model having our basic variables, the original variables, and the interaction term at 0.05 level of significance to see which interaction terms remain significant. And we use the stepwise approach. To run the stepwise, we shall go to statistics, go to other, and then we go to stepwise estimation. In this dialog box, we have the command here where we specify the type of regression we are running. If we click on the drop down arrow, you can see we have almost all the types of regressions. Our linear regression is having the regress command here. And the dependent variable is our systolic blood pressure. Then we are going to add the terms here. If you have earlier versions of STATA, you can see that the regression terms were here and the command was on this other side, where you have to specify term 1 and you put the variable that corresponds to term 1. Then after that you go to term 2 and specify the variable that goes to term 2. For newer versions of STATA, this is what you will see. The terms are added in this other format where you just click add, and then you specify the term you want to put there. Then you click OK, and it is added there. If you want to add another term too, you just click there, and then you add a second term. These are like the variables in our model. So then I will click OK, but I will not go through this tiresome process of adding one term at a time. What I'm interested in here is to get or to show you the command you would use. So once I just put any 1 or 2, I just click on OK. Oh, sorry. I have to specify the significance level for removal from the model. So what we are doing, we are starting with all the variables in the model, and we only retain those that have a p-value less than 0.05. So click OK. And then you will get your command here with the analysis. Remember, we've not put in all our variables because of laziness. I just wanted to get the command here, and then you can see that we have the command, and then here it is easier to just add on the rest of the variables. We have gender, we have smoking, we have the interaction terms here. It is easier here, I think. BMI smoking, and then gender smoking. Enter, and then the model will run. It will remove all variables with p-values that are above 0.05 that we've just specified. Only one variable age has met that condition of having a p-value less than 0.05, indicating that we do not have interaction effects among our independent variables in our model. I want you to remember that when we were asking ourselves how many interaction terms can we form to assess for interaction, the first scenario was whether you do not have a main exposure. And if sample size is adequate, we form interaction terms among all variables. However, if still we do not have a main exposure and our sample size is also inadequate, then we shall use a method that we've just applied, the stepwise method, this time round on our very many original variables or the basic variables, to first find those that are statistically significant so that we form now interaction terms among only those. Because you may have over 20 variables, you cannot go ahead to form interaction terms of all those 20 variables. So first run a stepwise of only those basic variables so that you remain with those that are significant, even it may be 3 or 2, they are the ones you form interaction terms amongst themselves. So if my sample size was inadequate, I was going to first run a stepwise for all my basic variables. Remember, at this point, I'm still asking myself how many interaction terms can I form. So I don't have any interaction term based on the variables I have. So I'm going to run a stepwise with the 4 basic variables here: age, BMI, gender, and smoking status. So I will run this, and you see that I only have age. This is just for demonstration purposes, but in real life data, you will have at least more than one variable here. So if we only have here maybe age and maybe gender remained here, we would only form one interaction term between age and gender, those variables that have remained in the model. And after that, we go ahead to run another stepwise with that interaction term to see whether it remains significant. The second scenario we can look at when we are asking ourselves how many interaction terms can I form is when you have a main exposure in your research. By main exposure, we mean if instead of your question being what are the factors associated with the blood pressure, instead the question was, is age associated with the systolic blood pressure? Yes, our main focus is on age, but we also have these other variables. So in this case, age will be considered a main exposure. So in that case, if you have a main exposure, only form interaction terms with the main exposure. So you are going to form interactions between age and BMI, age and gender, age and smoking status. Those are the 3 interaction terms that you're going to form. And after forming, then you will go and run the linear regression, the stepwise here. In this case, we are going to have the regression with the basic variables, but with only 3 interaction terms. The one of age with BMI, age with gender, age with smoking. So those are the only 3 interaction terms we would form, and then we enter. Still, we would have similar results like what we've seen before. And based on this, we can still see that none of the interaction terms was significant, so there was no interaction in our model. If you ran your analysis and you found that a certain interaction term is significant, for example, if assuming this age BMI was statistically significant, sorry, I don't want now to run a stepwise. If you just ran this and you found that assuming this was statistically significant, then the 2 variables that are forming that interaction terms must remain in that model whether they are significant or not, they have to remain there. You can't have a higher order term, an interaction term significant when the basic variables are not. Another bonus tip here, if you didn't want to manually create these interaction terms, which you don't even know whether they will be significant or not, you could use a shortcut of just putting a hash between two variables. For example, the interaction between age and BMI is just putting age hash BMI. It tells STATA that this is an interaction term. But being linear regression, we have to tell it that this is both variables that we are multiplying. They are continuous variables, so that the software can see a possibility of creating a multiplication between two numeric variables. That's why you see c dot each variable telling STATA that these are continuous variables. So if we run this, it is equivalent to what we would have run here with the variables created manually from this side. So we would get this using this command where we have created the variables, and using the command with only hashes, we have the same output. If you found this video useful, consider liking and subscribing to the channel so that you don't miss out any of our future episodes. In our next episode, we shall look at how to assess for confounding in multiple linear regression analysis. See you in the next episode.